A whiteboard is visible and slides.
Yes, sir.
Okay. So let us start. Today's topic is a bit important because we'll be discussing about data transfer in wireless LAN. And before doing data transfer, we should understand about the 802.11 frame format. Now, the important thing which you can see here, apart from other things, that there are 4 addresses in 802.11 frame, 1, 2, 3, and 4. In 802.3 frame, if you remember Ethernet 802.3, there used to be source MAC and destination MAC. So source MAC address and destination MAC addresses. Only 2 addresses used to be there in 802.3 frame. But if you see 802.11 frame format, there are 4 addresses, 4 MAC addresses, 1, 2, 3, and 4. And that's what is the focus today, that what is the use of these 4 addresses and how these addresses are going to be used. Another important thing which we are going to discuss is, because 802.11 alone cannot work, it has to connect with our wired network also, 802.3 also. So how this conversion of frame take place? How the 802.11 frame can be converted into 802.3 frame and vice versa. So these 2 important things which we are going to see today, and then we'll take some case study of data transfer. If you see 802.11 frame format, 2 byte of frame control, then the duration ID. Duration ID suggests that how long network is going to be allocated by a particular station or by a particular frame, what is the size of the frame. Then there are 6 byte 48-bit MAC addresses, 4 MAC addresses are there. There is a sequence control because we do have acknowledgement mechanism in 802.11. So if your acknowledgement is missing and you are sending a packet again, to control the duplicacy of packet, we have sequence numbers. We do have data. And then as before, we have cyclic redundancy check. Type, what type of frames are going to be there? That is going to be covered in frame control 2 bytes. What is the type of the frame? There are 3 main types: control frames, management frames, and data frames. Control frame, you have seen the acknowledgement, the RTS, the CTS. Later on, we'll see the power management and all that. Management frame is for your roaming, authentication, de-authentication, joining with the access point, leaving from access point, and data frame as usual. Sequence number to decipher the duplicated frames due to lost acknowledgements. We have got 4 addresses: receiver, transmitter, BSS identifier, and sender. We'll see these things in detail, that what are the uses of these 4 addresses. And miscellaneous, we have sending time, checksum, frame control, and data. We will not be working in detail regarding this. Our main focus is the usage of these 4 addresses and how the conversion can take place from 802.11 to 802.3 and vice versa. Now, if we see the first field, if we see the first field, the frame control of 2 byte, these 16 bits are going to be again demarcated like this. The protocol version, there are many versions of 802.11, A, B, G, BG, N, AC. In last, say, 15 years, many versions have came. The type means whether it's a control frame or management frame or a data frame. Then there are subtype also. We'll come back to this later on. These two bits are important. To DS and from DS. To DS can be said like to AP also, to access point. And then from DS can also be known as from access point from AP. Then there's last fragment, whether it's a last fragment, whether you are retrying. Uh, some more data is coming is if fragments are getting used, the power management, and some EP fields. We'll see about EP later on. Now let's see that what is the meaning of these four addresses and to DS and from DS. And accordingly, we'll be having the case study. So if both to DS and from DS are 0, let's see. Let me switch to the whiteboard. What I'm saying, if 2DS or 2AP is 0 and from DS or from AP is 0, in this case, this is the case where two nodes are trying to communicate using 802.11 without using any infrastructure device, without using any AP, any access point in between. Then 2DS, nothing will go to the distribution system or to the infrastructure network. From DS, nothing will come from the infrastructure network. And if 2DS and from DS are 0, it means two nodes are communicating in a peer-to-peer manner in ad hoc mode. And for doing this, you have to convert the access point from ad hoc mode to from infrastructure mode to ad hoc mode, as we have discussed in the previous turn, that your LAN card or wireless LAN card can be in two mode, infrastructure mode or ad hoc mode. When we are normally, most commonly, your LAN card is in infrastructure mode, where you communicate, two devices communicate, A and B communicate using an access point. But if you want to have communication peer-to-peer direct without using an access point, then you need to convert the mode of your LAN card from infrastructure to ad hoc. And then this particular bit combination, 2DS from DS, both are 0, is going to be used. Now, in this case, what is the usage of these three addresses? If you are having both 2DS and from DS 0, then first address would be the destination address. Second address would be the source address, means first address would be the MAC address of this node if it is a destination. And second address would be the MAC address of this node if it is a source. Now, what about the third address? Third address would be BSS ID or SSID. Now, in case of ad hoc network, when 2DS and from DS both are 0, address 1 would be the destination address, address 2 would be the source MAC address, address 3 would be the BSS ID. There is no access point here, so how to give the MAC address, third MAC address, which is actually getting named as BSS ID. In this case, the BSS ID is 48 bits are generated randomly, and these two nodes are considered to be a part of this BSS, basic service set, where BSS ID is generated randomly of 48 bits. This is not a common case. This is only used when you are using you are connecting two mobile or two wireless devices using 802.11 in ad hoc mode. So three addresses are going to be utilized in this case. The Address 1 would be the destination address, address 2 would be the source address, and address 3 would be the BSS ID, which is randomly generated, and address 4 is not used. It is not used. Now the next combination is 2DS, 2DS0, and from DS1. Let's see this case. When 2 is 0 and from is 1, this is the case when there are two nodes A and B, which are communicating using a access point. When A and B wants to communicate, suppose A is a sender and B is a receiver. So A data will go to access point first, and then access point will relay this data to B. This is the infrastructure mode, how infrastructure mode in infrastructure mode two nodes communicate. A and B can communicate using an access point. A will send data to access point and AP will relay this data to the destination. So here we are talking about this particular portion. When 2DS is 0 means you are not sending anything to infrastructure, and from DS is 1 means infrastructure is sending data towards the destination. When from DS is 1, from distribution system or from AP is 1, and AP, this particular portion we are talking about, AP to the node. And in this case, the combination, bit combination would be like this. As you have seen, to DS0 from DS1. Address 1 would be destination address. Address 3 would be the source address. What is the source address here? Anybody?
Sir, the MAC address of the access point.
MAC address of A, because in any case, AP, when AP is transferring data or relaying data towards B, AP must have got data from somewhere. And that somewhere in this case is A. So address 3 would be the source address. Fine. And address 2 would be the BSS ID. BSS ID means the MAC address of access point. MAC of access point. So whatever is the MAC address of access point, that would be the BSS ID. When an AP is connected, you join to AP using SSID, and that is what I'm talking about. So this is the MAC address of the AP. In this range of AP, nodes who are joining to this access point. Okay, using this MAC address. So in this case, when you are transferring data from AP to the node, obviously it must have arrived from some source node. So address 1 would be your destination address. Address 3 would be your source address, and address 2 would be the BSS ID. Now the third combination is when you are sending to DS, when node is sending towards the distribution system or towards the AP, means this particular portion. When A is sending to B, so for A to AP, it would be 2DS. And in this case, to field would be 0. From field would be, to field would be 1. And from field would be 0. Means you are sending data towards distribution system or towards access point. In this case, what is the address combination? This is the address combination. 2DS1 from DS0. Address 1 would be the BSS ID. Address 2 would be the source address, means in this case MAC of A, and address 3 would be the destination address. Destination address means, what is the destination address here in this example?
So MAC
MAC
address
address.
of AP.
No, MAC address of A is the source address.
SS point. MAC address of SS point.
Access point address is address 1, BSS ID. Address 2 is source address, it is MAC of A. What is the address 3? Address 3 would be the destination address. In any case, when you are sending it to access point, you want to transfer it to somewhere. So what is your actual destination? Access point is not your actual destination. Your actual destination is, in this case, it is B. So it would be MAC of B. Any questions here?
Sir,
Yes? Speak loudly.
no question.
Sir, what will be the BSS ID?
What would the BSS ID? It is the MAC address of the LAN card of access point.
Okay.
Access point is nothing like a special node. It is again a wireless node, which is just doing the relaying work, relaying job. Now, if we want to see it in another manner, address 3, address 1 can be considered as what? Let's focus on address 3, address 1 and address 2. Because you are not required to mug up each and everything. Address 1 is actually the receiver address. And address 2 is transmitter. Now let's see all the cases again. In first case, when there was no access point, to DS and from DS both are 0, then you can see address 2 is transmitter, which is source address also, the wireless transmitter from node A to node B directly without any access point. So address 2 is transmitter, and actually right now the source address is also the transmitter address. Address 1 is receiver, and destination address is the receiver also and the destination also. Got the point? Let's take the next case. From AP means, just a minute. Let's see the second combination, that from AP. From AP means node A wanted to send to node B, must have sent to node AP, and now AP is trying to transfer to B. This case, from AP. Now, if we see from AP, who is the receiver right now? Receiver is destination address. From AP to B, receiver is B, and it is the destination address also. Who is the transmitter right now? Transmitter is BSS ID. Right now, AP is transmitter. So that's why we are using the BSS ID. Actual source is in the third address, which is node A. This point is clear? Tell me, bachcha log, this point is clear?
Yes, sir.
Address 1 is receive. Sorry. Address 1 is receiver. Address 2 is transmitter. When we are taking second combination from AP, means AP is in between. There is node A and there is node B. We are talking about this portion AP to B from AP. In this case, address 1 is receiver, which is what? Destination address. B, no problem. Address 2 is transmitter. Obviously, AP is transmitter right now. So BSS ID means MAC address of AP. Actual source is address 3, which is the address of A. If we take the third combination, 2 AP. Suppose A wants to transfer to B via AP. So this portion, 2 AP, if you want to see. So in this case, address 1 is receiver. So obviously, it is BSS ID. So right now the receiver is access point. Address 2 is transmitter, which is source address, address of MAC address of A, and actual destination is B. Actual destination address is MAC of B. This point is clear to everybody, these three cases.
Yes, sir.
Any questions?
Yes, sir.
Now let's take the fourth combination. Let's take the fourth combination. So what is the fourth combination, which is not very common, but maybe utilized basically in the mesh network? Suppose this is AP1, which is wirelessly connected to AP2. This is 802.11 in between AP1 and AP2. There is a node A wirelessly connected to AP1. There is node B, which is wirelessly 802.11 using 802.11 wirelessly connected to AP2. Now, if A wants to transfer data to B, so obviously A will transfer to AP1, AP1 will transfer to AP2, and AP2 will transfer to B. Now, in this case, that is the fourth combination, which is not very common. That is the fourth combination. What is that? 2DS, obviously 1. You need to send to 2DS. From DS, again 1, because DS distribution system or access point want to send also. So both are true, 1, 1, 2 and from. 2 from both are 1. What is the combination? Address 1 is what I told. Address 1 is receiver. Address 2 is transmitter. So who's the receiver right now? AP2 is the receiver. AP1 is the transmitter. So address 1 and 2 is receiver and transmitter. AP2 is receiver. Either it would be AP2. Transmitter would be AP1. Who is the actual source? Actual source will go to the address 4. Who is the actual destination? Actual destination is node B, which will go to the address 3. In this case only, all these 4 addresses are going to be utilized. So this is RA, this is TA, this is the actual destination, and this is the actual source. Any confusion? But mind you, here AP1 and AP2 are connected by using 802.11. And in this case, all the four address 1, 2, 3, and 4 are going to be utilized. Not a common case, but in wireless mesh network, we use this type of topology where the backbone also is connected in a wireless manner. Any doubts here in the fourth combination?
No, sir.
Yes. Priya, any doubt?
No, sir, no doubt.
Anybody else? So we have seen there are 2 bits. 2 bits means 4 combination. When both are 0, 0, it is ad hoc network. And then we have seen how these 4 addresses are going to be used. Fourth is not going to be used. When it is to DS0 and from DS1 means you are getting data from the access point. Then how these addresses are going to be used? Then we have seen 2DS1 and from DS0 means you are sending from node to the access point. How these addresses are going to be used. And the fourth case is where both to DS and from DS are 1. And in that case, these access points are also connected using a wireless protocol 802.11. And then all these 4 addresses are going to be used. So the important thing here to keep in mind that address 1 and address 2 are actually wireless transmitter and receiver. Whenever there is a doubt, address 1 is wireless receiver, address 2 is wireless transmitter. Got the point? So let's take the cases. Let's take the cases slowly and gradually and how we can transfer the packet from one node to another node. Let's take the case number 1. So there is an access point. Let's call it WAP1. There is a node A which is connected with access point. There is a node B which is again connected to the same access point. Now I want to transfer data from A to B. So we are not talking about ARP right now. ARP can be done similarly. Considering A knows the MAC address of A, suppose knows the MAC of B. Now how A can transfer data to B? How these addresses are going to be used? So obviously A will transfer data to B using wireless access point. So this whole communication will be divided into 2 parts. Towards access point and then from access point. So you can consider wireless access point as a wireless switch, wireless L2 switch. In L2 switch also what you used to do, A will send to layer 2 switch and layer 2 switch will do the switching and transfer to the B. Now how the things are going to be done, let's see. So when A will send the MAC frame, the frame of A 2DS and from what would be the value in the first portion? 2 would be I want to transfer from A to B. Data will go from A to access point and then access point to B. So initially when A transfers data, what would the values, what would these 6 values? That's what I'm saying.
1,
What
0.
it would be 1, 0. What is the address 1? Address 1, 2, 3, and 4. Address 1 would be?
B.
Hmm?
MAC
MAC
address
of
of
MAC of
B. It is
MAC
destination name.
MAC of
access point.
MAC of access point, MAC of AP. Fine. It is BSSID. Okay. Let's see here. 2 AP, 2 1 from 0. Address 1 would be what? Right now, what is the receiver? Receiver is access point. Right now, what is the receiver? Receiver is access point. Address 1 would be the MAC of AP. What is the MAC of address 2? It would be MAC of
A.
MAC of A. The right now, what is the transmitter? What would that address 3?
MAC of B.
MAC of B. Actual destination, MAC of B. And that's what is written here. BSSID. This is the right now receiver. Address 2 is right now transmitter or the source address. And actual destination would be in address 3. Address 4 will not be used. Got the point? Now what access point will do? Will relay this packet from access point to B. In this case, the to field would be 0. From field would be 1. In this case, what will the address 1?
Sir, B.
So destination MAC address.
Right now receiver is MAC of B. Right now transmitter is what? From here to here. Right now, what is the transmitter?
Access
BSSID.
point.
BSSID. Access point MAC address. And what is the actual destination? Actual
B1.
destination is MAC of B. Got the point? So in this case, you can see here, when you are getting from AP to DS will be 0, from DS will be 1. Address 1 would be the actual receiver. Address 2 would be the address 1 would be the right now receiver. Address 2 would be the right now transmitter, and address 3 would be the actual source. Got the point?
Yes.
I'll explain it again. Shall I explain it again?
Sir, what will be in the third address field?
Okay, so let's do it again. WAP 1. Suppose the MAC BSS ID is means MAC of WAP is MAC of W. There is a node A, there is a node B, wireless. A's MAC address is MAC of A, and B's MAC address is MAC of B. Now A wants to transfer data to B, and we are assuming that A knows the MAC of B. Now this data transfer would be divided into two parts, from A to access point and from access point to B. So for this part 1, 2DS would be 1, from DS would be 0. Okay. Address 1 would be what? For this part, who is the receiver right now? Address 1 would be what? Priya?
Sir, BSSID.
BSSID, which is MAC of W. Okay? BSSID. Address 2 would be what?
MAC of A.
MAC of A. Address 3 would be what?
MAC of B.
MAC of B. In second part, 2 would be 0. From would be 1. Address 1 would be what?
MAC of B.
MAC of B. Address 2 would be what?
BSSID.
Means MAC of W. And address 3 would be what? Actual source?
MAC of A. MAC of A.
MAC of A. Got the point, everybody? So in this way, A to B transfer can happen. Any confusions here? Is there any question, any doubt you can ask here? Now let us take another case. Let us take another case. Now in this case, what is happening? There is a L2 switch. And from the port of L2 switch, wireless access point 1 is connected. Another port of L2 switch, wireless access point 2 is connected. Fine. There is a node A, which is connected to wireless access point 1. There is another node B, which is connected to wireless access point 2. Between A and wireless access point 802.11 is there. 802.11. So there is a wired LAN card in access point, as you have seen in your wireless routers, wireless access point, wired LAN card. And between wireless access point, so there is a wireless LAN card through which it is connected to A and B. There is a wired LAN card, and between access point and L2, it is 802.3. And between L2 to wireless access point 2, again 802.3. Fine. So obviously here the frame which is going to access point, it is frame of 802.11, which cannot travel as it is in this part, because here it is 802.3 is running, who has got different frame format. The frame format of 802.3 and 802.11 are not same. So we need to do a conversion or translation from 802.11 to 802.3 and vice versa here from 802.3 to 802.11. Understood the case? Priya?
Yes, sir.
Now we will be focusing on these 6 fields only. 2DS, from DS. In 802.11, there are 4 addresses, rather 3 addresses. And in 802.3, there are 2 addresses. So how this is going to be done? This is what we are going to see. Got the point?
Yes, sir.
Okay. So A wants to transfer to B. So obviously A will send to the access point. A does not know whether access point is directly, where is B? A does not know. We just know that A knows the MAC address of B. A knows. We can assume this. If does not know, then you can run ARP. That's the same case. There is no difference. So A wants to transfer to B. A will transfer to wireless access point. So let's have the MAC addresses. MAC of A is MAC A. B it is MAC B. AP1 is MAC of W1. AP2 MAC address is MAC of W2. Now from A to B transfer, actually there are 4 parts. From A to access point, 1 part. From access point to switch, 2nd part. From switch to access point, 3rd part. And from access point 2 to B, it is the 4th part. Okay, bacha log. Let's see the first part. First part, 2 field is quickly
1.
1. From field is 0. Address 1 is receiver current receiver. It
Yes,
is
sir.
MAC of
W.
W1. Okay. Address 2 is
A. Back of
MAC of A. Address 3 is
MAC of B.
MAC of B. Now, if you see 802.3 frame for format, there are nothing like 2 DS from DS. There are only 2 addresses. So how this translation happens? This frame will reach to access point 1. Now this frame has to be transported to this part, 802.3. So what is going to be done? In 802.3 frame, source MAC would be address 2. This address 2 would be copied in source MAC. Destination MAC would be address 3. This address 3 would be copied in destination MAC. Got the point?
Yes.
Got the point? Now this packet will reach to switch. What switch will do?
It will send it to WLAN.
Switch will send it to the AP2. Why? There may be AP3 also. There may be AP4 also.
Which might broadcast to all other than WLAN.
No, because switch might have learned about the location of B, that B is right now part of wireless access point 2. In this case, just see here, you are getting a 802.3 frame whose source MAC is MAC of A, destination MAC is MAC of B. So switch can learn, no, that this particular port is having MAC address A. Similarly, B might have communicated earlier. So switch has learned that this particular port is associated with B. Layer 2 switch functionality. Any confusions? Remember the MAC table of L2 switch? Priya?
Yes, sir.
So what was there in L2 switch? Suppose there are two ports. Node A is connected here, node B is connected here. So in the MAC table, it would be now port number
MAC.
is associated with MAC of A, 2 is associated with MAC of B. ऐसे करके टेबल बनाते थे ना? Same
MAC of
situation here.
and
Now suppose in L2 switch, this port is connected to a hub where 4 nodes are connected, A, B, C, and D. What would be there in the MAC table? Port number 1 is associated with 4 MAC address, A, B, C, and D. Suppose there are another nodes also connected with wireless access point, C and D. So this port number 1 is associated with A, C, and D. Switch will learn this. Got the point?
yes, sir.
So switch will forward this packet to this direction with source address as MAC of A, destination address as MAC of B. It will reach here. Now what WAP2 will do? It has to again convert from 802.3 to 802.11. What it will do? Two DS would be
0.
0. From DS would be 1. Address 1 would be
B.
B. Address 2 would be
MAC W2.
MAC of W2. Address 3 would be
A.
A. And in this way, conversion or bridging can be done and packet can be transferred to B. Got the point?
Yes.
Any questions here? Any questions from anybody? in both of these case studies, the first case study was there was one access point and both A and B were connected to the same access point. And if we assume that A does not know B's MAC, obviously A knows B's IP. And second case study also, L2, AP1 and AP2. A is connected and B is connected to AP2. So A does not know here also the B's MAC, but A knows the B's IP. What will be done in both these cases? Yes, Priya.
Yes, sir.
Suppose you don't know the MAC address of B. A does not know the MAC address of B.
ARP, but
Obviously. So ARP would be running. ARP would run. So instead of actual destination giving B's MAC address, in actual destination you will be giving all F. And the same process which we have used is going to run, and then B will reply back, and A can know the MAC address of B. So the ARP procedure which we have used in the wired network, similarly it will run in the context of 802.11 also. This I am giving you as an assignment. Need not to submit, but just try this and try to solve this. Tell me one question. Suppose there is AP and there is a node A and there is node B. They all are connected to same channel, obviously. In 802.11, we are, if we use 2.5 gigahertz channel frequency band, we have 11 channels, 12 channels rather, and non-overlapping channels are 0, 6, and 11. Just to, so means if we want to put two APs in the same wing, one would be working on one channel, sorry, 1, 6, and 11. 11 channels, 1, 6, and 11. One would be working on one channel. AP2, which is nearby, should work on channel number 6. Otherwise, there would be co-channel interference, physical layer stuff. So this AP1, A and B are working in same frequency range. All these would be working on same frequency channel. Now, important point here is all these three would be considered as three wireless nodes competing or contending for the channel. So the CSMA CA protocol we have seen in the last lecture, that distributed coordination function, These three are the contending node. AP is not a spatial node. AP is also a wireless node which is contending for channel A, B, and AP. These would be contending for channel. Listen to the channel, wait for the IFS time, then again wait for the slot time if it has missed the chance and things like that. This is the important point I want to tell to you guys. If there is any doubt, you can ask. Any questions? Oh, okay. If there are no question, then we can stop here. Please do the assignment and ask your CR to tell me the time for tomorrow. I can again take one class tomorrow of 1.5 hours. And in the next class, if there are no questions, we'll start the mobile network layer, the mobile IP. Got the point? If there are no question, then you can leave. Thank you.